Okay, so we're going to look at classification and biodiversity review sheet. We're going to go through the answers and just go through a few things that maybe you don't quite know. So let's go to our first box and we're going to look at then how a species grouped. So how a species grouped, they're grouped by their similarities. We know that we're grouping things by the similarities and what characteristics they have. And they are grouped into 5 kingdoms, okay? And we only looked at 2 kingdoms, and the 2 that we looked at, we looked at the animal kingdom and we looked at the plant kingdom. They were the 2 that we had to look at, but we need to know that there are 5 kingdoms. So how are they grouped further? So we've got every single animal, and we said that how we group them into vertebrates and invertebrates. And if we can't remember, vertebrates are animals with a backbone. Okay, so for example, we've got a backbone and we cannot use the word spine. We have to say backbone because it all depends what the spine is made of. It can be cartilage, which technically isn't a backbone. So then we have invertebrates, they are animals without a backbone. Okay. And then how are plants grouped then? Plants are grouped into whether they are flowering or non-flowering. So if they produce a flower, then they're a flowering plant. Then look at how do we name species. So we use the binomial system to name species, and it's their scientific name. It's there to name their scientific name. Like for humans, it's Homo sapiens, our scientific name. So as we know, we have classification categories. We have kingdom, phylum, class, order, family, genus, species. And we take the genus and the species of the organism and use it for their binomial name. And it tends to be in Latin. The name is in Latin, and we use it because it is then universal, so it can avoid our confusion. If it comes up in the exam, we are looking for this keyword here. We are looking for universal. So make sure we remember universal. So let's go up and we can look at then how are organisms adapted to their environment. I've just chose 2. I've chose the polar bear, and it's got the Arctic environment. So it's got thick fur, and the reason then to keep warm. We have white fur then because it's camouflage in the snow from predators. They also have small ears. Remember, we can't say to keep warm, it's going to be to reduce heat loss, because they are still going to lose heat, but the smaller the ears, the less heat they're going to lose. Then we have the layer of fat, and again to keep warm or for insulation. I then chose a camel in the hot desert environment. So as we know, a camel's got long eyelashes, and it's essentially to keep the sand out during sandstorms. And then they have the beige colour fur, which is then for camouflage against the sand. They have their hemp, who can't say stores water, because it doesn't, but it stores fat, which could be broken down to make water. They also have long legs, and it's to keep their body cool, because if we've all been on the sand in the summer, the sand is really, really hot, so it stops them absorbing heat from the sand. Then we're going to look at then why should we take a sample area if we're looking at a sample to look at distribution of organisms. And we do that so it's to minimise impact on biodiversity. We don't want to cause any harm or any distress to any animals or except species. So we do it to minimise impact on biodiversity. Why is it difficult to sample a whole population of an area? Well, the area could be too large. Okay, we're looking at like the ocean, for example, or a lake could be too large, and the population could be fast moving. So it'd be really, really hard to actually count them, or they could hibernate, for example. We're not actually going to see all of them. We then have what techniques can we use? Well, we can use quadrats, and we can use a transect. So the transect is the transect line that we had, remember, then we put quadrats along it to count the number. So how do we use a quadrat? We use the quadrat then to estimate population size. And what we need to do, we need to randomly place our quadrat in the field. Okay, that is a key. We need to randomly place it. Okay, we can't be biased, okay, and decide there's not many daisies. It needs to be random. Then we count the number of daisies in the quadrat. Then we repeat for 10 quadrats, okay, or more. The more you do, the more reliable your result is going to be. Then what we would do then, we would calculate the mean for the number of daisies in each quadrat. And then from that mean, we would times the mean by the area field to get a population estimation. Then, what is biodiversity? So biodiversity is the number of different species, again, different being a key word here. Okay, we're not looking at the same species, we are looking at different species living in a particular area. So the more number of species we have listed there, the more biodiverse it is. Why is it important? Well, it's important because we can make new medicines. It can regulate the atmosphere, so the amount of carbon, the amount of nitrogen in the atmosphere, to make new foods, and it's good for industry in building and building materials. So how can biodiversity be protected? We can use SSSIs, which are sites of special scientific interest, which are used, people can't go on, we can't build on. We have national parks that protect the habitats of many different species. We have conservation schemes, which we know, like WWF. We have zoos, they are our breeding programs where they look to breed to try and increase the numbers of endangered species in a population. Again, remember, biodiversity is for plants as well as animals. We have seed banks, where we have banks of seeds of all endangered plants, or all plants, so we can grow plants if they're becoming endangered and then take their seeds to replenish. Then we have CITES, which is the conservation and trade of endangered species, where we're unable to trade endangered species. So we can't then go and essentially buy a black rhino on. Then we have, why might the population of a species fluctuate? So why might the population size of a species go up and down, etc., not stay at a steady number? Well, they could have disease, depending on where they live. They could experience a bit of disease if there's too many, overpopulation. The amount of predators they have, their predator population could increase, which could cause that species to decrease, or vice versa, their prey could increase, so they would increase, or their prey could decrease, they haven't got enough food to live on. The number of births and deaths could increase and decrease over a period of time, and we could have a lot of immigration or emigration of the species in a particular area. And then just the availability of food or shelter. If we have their shelter taken away, then the population will decrease until they find a more suitable environment to live in. So that is our review sheet for classification and biodiversity. Thank you.